Hello, I'm Dr. David Warren. Thank you for joining us to listen to our open day presentation, whether you're coming back from the event itself or if you weren't able to attend the opportunity. Hopefully you'll find the next series of slides informative, and if you've got any questions then please drop us an email at m2a@swansea.ac.uk. So quickly, an introduction to what the Materials and Manufacturing Academy is. So we're a postgraduate training project. We're funded via a series of government funders, so the Engineering and Physical Sciences Research Council, the Welsh European Funding Office, which uses European structural funding, industry, as well as Swansea University. The M2A itself incorporates a prestigious CDT in functional industrial coatings, and that produces highly skilled postgraduates in engineering and materials. And across the two sides then we've got NGD and MSc projects, which are all sponsored in partnership with industry. That's one of the key things about the M2A, is that all of our projects are being sponsored by industry. So it's a key opportunity for you guys to be able to work not only on your education but also getting that valuable experience of working with industrial partners, understanding some of the industrial processes and the relevance of how the research maps across into those industrial processes. The other thing with the M2A is that you'll be joining a cohort of around 100 research students. So there's a big group, which means you're all coming through it together. There's lots of people who will be like-minded, and it's a great opportunity to make new friends or keep other friendships going. And for many of our students, then they'll be making a big group of alumni who you can work together and continue the partnerships going into your careers. For those who've not experienced with Swansea University, the university itself was established in 1920 by industry, so we've always had these close links with industry. Originally with the copper industry that was in Swansea, and that's developed over the years. We're a close partner with the steel industry, but a lot more businesses as well. The university itself is what's referred to as research-led. So that means we focus a lot on our research and make sure that research then is fed down into the teaching side of it. So we've got a lot of experience and a lot of ability when it comes to being able to deliver these research projects. In terms of rankings, we're a top 30 research university in the UK, and engineering itself, which is where our focus is, then we're ranked 10 in the UK, and 94% of our research is either world leading or internationally excellent. So we're really good university when it comes to being able to deliver this industrially focused research. One of the key things to us is that we're located on a purpose-built Bay campus. This opened in 2015, and it meant that we're able to develop a lot of our facilities. We've renewed a lot of our equipment, and we're a purpose-built campus which combines engineering and management. So the engineering department sits in this region, so we're part of a faculty now. So it's the Faculty of Science and Engineering, and all of this part of the university is dedicated to that. These buildings here, this is our library. This is a great hall where we hold a conference every year, and then we've got accommodation over this region, and the building hiding behind there is our School of Management as well. So the idea is that we can link in this industrially relevant work, but also being able to tie that in with some of the business aspects as well. So how can we commercialise and take some of our ideas forward. So for most of you coming here, then we'll be sat somewhere around this region. So if you come through your graduation, whether that be a postgraduate or an undergraduate, then you've got two options really. You can either go into a graduate position and look at your funding opportunities and take on your career straight away, or you can look at your postgraduate options. So either going into a postgraduate taught scheme where it's a fully taught program, or you start to look at research, and this is where we fit in. So we offer two research programs, which is the NGD and an MSc. The NGD is similar to a PhD in the sense of the academic content, although there's the definite link with industry, and also there's a teaching component which we'll get onto shortly. But this is our options. This is what we're really looking at and what we're talking about today. So here's a short video of or introduction of the scheme.
the M2A is an overarching umbrella title for projects which encompass doctoral and master's training within Wales, and it covers the area of advanced materials and manufacturing. Within the M2A we have a prestigious EPSRC CDT, which is called Coated, and that focuses on projects to do with functional coatings. All our projects are sponsored by industry, so our students get an amazing experience of working on an industry-focused problem. And not only that, they're embedded within the industry for a 4-year period, so in terms of employability and opportunity for the student, it's a huge advantage in terms of their future career. It's a fantastic opportunity not only to gain experience of working in industry on a dedicated industrial problem, but working in an unprecedented scientific research environment with some of the best kit in the world, leading technologies. They get huge employability benefits through our training program. Students who work in the Coated CDT within the M2A get access to sector-leading facilities. The ability to work from the laboratory scale right up to the industrial scale is an opportunity that is unique really to our centre. Some of our alumni have gone on to work in this sponsoring company and are now at director level, so the skills that are embedded within the student through the opportunity of the scheme really makes a massive difference in terms of their future career. So in terms of our student population, we encourage them to travel out to companies across the world, but also to international conferences where they get to present. And within the coatings field, a lot of those conferences are held in the US, places such as Hawaii, Los Angeles, across the world in terms of Europe and Australasia. So it's an amazing opportunity to go and see the world whilst also presenting your leading research. What we try and do within our portfolio of projects within Coated in the M2A is cover a diverse portfolio of coatings-facing projects. So there's a massive opportunity to work at the cutting edge of science with projects through the M2A.
We're working with the M2A program, so we have a student here for 4 years. We've got a proven model for calculation of noise through one of our devices, and that has led us to now bid on projects, and it's resulted in us winning the largest ever order for this particular product line for Vietnam, so it's been a super success.
An environment in which we nurture young talent, and give them the space, the support and the training to deliver new and innovative solutions to real-life, industrially relevant problems. We at Tardis were one of the founding partners of the original engineering doctorate scheme way back in 1992. At the time it was very much focused on collaboration between Strip Products business and Swansea, but has since grown to encompass all of the Tardis UK businesses, other universities and some of our supply chain partners.
Okay, hopefully that gave you a good snapshot of what we're about, and we're finishing off with some examples at the end there of our annual conference, which is a fantastic opportunity where we get to share all of our research, not only with our colleagues in the different departments at the university, but also a wide range of different government and industrial partners that come and attend the event. So we've got to look at some of the incentives and some of the benefits of coming to work with us. One of them is the stipends that are attached to our qualifications. So we've got the graduate starting salary varies between where you are in the country, what sort of roles you're going in, what discipline you come from. You're talking as a benchmark, you're talking around the £25,000 to £1,000 mark as a graduate salary. Coming into the study with us, we actually give you a stipend as opposed to a salary, and one of the key things with that is it's tax free. So we have to take that in consideration. You've got the benefits of you don't have to pay any deductions, there's no student loan deductions coming from it, and there's no tax. And on top of that, then you're also eligible for reductions in council tax as well, because you're still viewed as a student. So in addition to these figures, so we pay £20,000 for an NGT or 12.5 for an MSc, and that's per year, £20,000 per year for the NGT, and the MSc is 1 year. Trying to bulk that out, it's about £27,500 for an NGT. The MSc works out as around £15,000 salary to give you a benchmark. But on top of that, then you're obviously getting a qualification, and those qualifications need to have been highly employable. So you're getting an employability rating with us is 97% of our students are getting out into employment and getting good employment as well. A quick snapshot of this is by no means based on real life data. This is purely indicative, but a lot of the decisions people make is, should I go into this bachelor's graduate route and just get on with my career and get earning about the and getting that experience, or do you follow this postgrad research route? And one of the things we see with that postgrad research route is, yes, that your start in your career and your progression is a little bit slower, but what you see once you're into the workplace, then for a lot of our graduates, we're seeing is that they get this rapid acceleration in terms of where they end up progressing. So in terms of making that decision, that's something to bear in mind. Money's not everything for everybody, so some people are more than happy just to sit around and with their ambitions. So we won't say the money's everything, but certainly for a lot of people, we're looking at our career prospects, and for a lot of our NGT and MSc graduates, and they do get themselves into good positions and good prospects. On to some of the important stuff, and that's the eligibility for our funding. So education wise, we need to come in with a minimum of an upper second class honours degree from bachelor's. You must have the legal right to live or work in the UK at the start of your studies, and a student visa isn't sufficient to meet that criteria. And then when you move or when you start your scheme, you have to move to the West Wales and the Valleys region, which is the area shown as the darker pink in this map here, and that's key to us achieving our funding. The other side of it then is that you're not able to self-fund your studies. So if you're the government funding is provided to us on the basis that you aren't able to fund your own studies. So we do ask for evidence of that. So say no, you shouldn't have savings in excess of £71,000 that you're able to evidence. Full details on this can be found on our website. So what is postgraduate study? The big change from an undergraduate style or a taught style research program to a research program is how we treat you as an individual. So it becomes more like a job. There's an expectation of a 35-hour working week. So you come in Monday to Friday, you work a 9 to 5 kind of day, and there's a lot more onus on you to get on with it yourself. So the pressure, not the pressure, but the drive needs to come from yourselves. And we're just here to support you through that journey. So it's your degree. So looking at the MSc, it's a 1-year program, so we don't mess around with courses for this. We get straight into the research. You get on with the literature review, and then get on to your experimenting, get the research done. There's quarterly review meetings that take place, and that's to give you practice presenting, share ideas, and to provide updates to your sponsors. There's an annual conference that we saw the images for in the video, and then you produce a thesis at the end of year 1. For the NGD, it's a little bit longer, so it's 4 years. We do our literature review with that, but there's also an initial 4 months of technical modules that are part of the NGD. So that's one of the things which is different about a PhD to an NGD, is that these compulsory modules take place in the first 4 months. and you take that as building up your foundation knowledge, giving you the skills, and then you get further professional training, which is in years 2 and 4, which is aimed to give you some of the professional skills. So the technical at the start, professional skills you go on, and the idea is that by the time you graduate, then you get in these added skills to make you highly employable, get out in the workplace, make a difference, and get onto that rapid career path. Again, we have quarterly review meetings, the annual conference. Because it's a 4-year scheme, then we expect an annual report at the end of years 1 to 3, and then at the end of year 4, again, back into getting that thesis done. A lot of people feel a little bit intimidated by the thesis. It's nothing to be intimidated about. All you're doing is writing about what work you've done. It's not something to be intimidated about. It's really something which celebrates your research by the time you get to the end of your studies. The training component then is compulsory for the NGDs, as we mentioned, but the MSCs are welcome to attend the modules. If you wanted to, there's not compulsory, but you can come along, attend the modules, and gain the extra knowledge if you so wish. We've also got the academic success program at the university, and there are other training opportunities both in technical and professional training. So we've got a lot of our researchers will go off and do specialised training. So we've some have gone to Scandinavia to work on software training. Others have gone to different regions in the United Kingdom with things like electrochemistry training, which is specialised for their project. But we'll also support professional training. So we've recently completed a Six Sigma training program, because that's something that's been identified as a key CV or key to have on your CV when you go into looking for jobs. Another thing which we've done as part of our training is we've got something called the BAME leadership program that we developed over the last 2 years. So we identified that working with colleagues that people coming from a BAME or BME background face extra challenges in terms of their journey to becoming a leader. So we went about and we've set up a specific training course that is designed to overcome some of those barriers. So it's a combination of leadership training and personal coaching, and that was delivered over a 3-month period and then supported with sponsors. There's 2 key differences in there in terms of what we do. So the combination of that leadership and the coaching was a big thing. So the coaching side of it was to address what barriers people are facing and try and give them the confidence to overcome them. But also the sponsors. So a sponsor is somebody from within inside the organisation. So there's a couple of examples. So a couple of the guys in the photos here are sponsors of the students, and they've been able to support our researchers in their journey and overcoming some of the barriers they're facing. And here's some feedback quickly for you off of Brimer.
My overall experience with the coaching has been extremely moving in a way that it's more about bringing the confidence that I used to shy away from out of me. So coaching was an emotional journey for me, because it actually taught me how to be emotionally stable and focus on goal achieving. Coaching was just perfect to just generate that positivity that I needed around the end of my doctorate as well, to actually achieve my goals, which I've been successful at achieving.
So it's really we've had really positive feedback from this, and we're looking forward to following the guys' journeys, and hopefully the feedback in 5 years' time is that this is still something which has helped influence them in their careers and really helped them to get on with
my
what
overall
they want to do. So back onto the compulsory training side of things, these are on the modules that we're offering. So as I mentioned, they were broken down into technical, their research, communication, professional skills. So this is just a range of modules which are compulsory. So the coaching side of things is the technical research, and then research skills, communication skills, which are critical to anyone's career, and then the professional side of it, so as I mentioned, entrepreneurship, economic appraisal of engineering projects, and leadership and management, and they're delivered towards the end of the scheme, and that's with the aim of helping to take your skills to the point where you can easily step into a leadership. So what do we expect out of you guys? So we want a thesis, so it's easy enough. You've got 1 or 4 years to get through it. As you mentioned, it's just about, you're writing about what you do. So have a quick look what other people have done. You do lots of research, really interesting research. You write up about it. You really understand it. Output your thesis. On top of that, we want journal publications, and that helps to build your academic profile, but also your profile in general, being able to put yourself out there as a leader in your field. Attend and present international conferences, which is a fantastic opportunity, and then to participate in outreach activities if you choose as well. So we really encourage our researchers and our students to get out there and give something back out to put more and more people into the discipline. As you all know, we need more people coming into the STEM disciplines. So we've got different groups and different committees that go out into schools and fairs and really help encourage more and more people coming into the discipline. So what to expect? Ultimately, I've got a journey into research. So it is a journey. We won't hide away from it. You have ups and downs in these journeys, but it's really enjoyable. You get in there and you really engage with it. You've got your peers around you, and it's about trying to get in there, understand your problem, and make the most of the opportunity. I've got in there as a challenge. As I said, we don't hide away from it. It's not easy. Everyone would have a doctorate if it was easy, but it's a process. There's a good structure here and the support, so we help you overcome the challenges and you come out the other side with your qualification. Access to facilities and equipment at the university is part of it. Support, there's a lot of that around for you, so we're going to help you through the journey, help give you direction, help give you ideas, and any other support that you may require. It's a development opportunity to get on, enhance your skills, enhance your CV. There's lots of opportunities to maximise, to get yourself into the conferences, opportunities to spend time in industry. You can share exchanges with different universities around the world as well, and then it's getting your experience up, and ultimately it's your prospects. You come out at the end and you step into new roles. So here's a quick video from one of our current participants giving a quick summary of her experience so far.
Yeah, so what I'm doing, or in my project, basically I'm trying to work out how to recycle more steel. So in steel, what there is various elements. Some elements you want to be there, such as silicon or manganese or carbon, and they're really useful, but some elements such as copper or tin are elements that you don't want to be there, but they're really difficult to get out of the steel. So what I'm trying to do is to work out how much you can get away with being in the steel, because that affects how much steel you can recycle. Because what happens at the moment is you can have about 20% recycled steel, and the rest has to be raw iron to dilute the unwanted elements to an acceptable level. Well, my project is important for sustainability because it looks at how to use the materials that we've already mined and we already have out the ground in a more circular and more responsible way. So hopefully having a more sustainable way of producing metal or steel in the future. So what I do specifically is I do rapid die prototyping. So this is using or making smaller versions of an industrial steel. So I work between 20 and about 150 grams of steel. So behind me you can see various machinery that we use to scale down the industrial process. And I'll then have my little tiny bits of steel that I've produced, and I'll do things like tensile testing on the tensile machine and hardness testing. And look at the microstructures and that sort of thing and try and compare it to an industrial steel. So I artificially add different levels of different residual elements, so copper and tin and this sort of thing, to sort of alter the chemistry and alter the composition of the steel that I'm making, and then test the different compositions that I've made to compare them against the industrial versions and my own baseline materials. So I like the NGD programme because it's a nice balance between going into industry and staying in academia, where I feel quite comfortable and I've been used to previously. But also I understand what I'm doing is relevant to an industrial or a real world perspective. And yeah, I really like being around people that are also interested in research and being in an environment where I'm part of a group also researching similar things. But I really enjoy using all the research equipment. I wanted an NGD project where I could use a lot of lab equipment and do a lot of physical hands-on work. So I really recommend it to anyone who's curious and wants to get into academia or into an industry role.
So hopefully that gives you a little bit of an idea of what one of our projects is like, and the experience that you can go through as you go through your projects. We've touched on support, so just to emphasise that we do have a lot of support around us with these schemes. So we've got our postgraduate academic supervisors who are there to give you guidance throughout the day. There's a team of us on the M2A, so there's myself, we've got 3 project coordinators, plus a full admin team to help you with everything imaginable in terms of getting over things. There's harassment officers around the university who can help if you ever face any issues, as well as wellbeing support, and there's a lot of online support as well available via the university as well to help with the with any challenges you may be facing. Just to touch on the supervisors, so each student will be given at least one academic supervisor and one industrial supervisor. Some projects will come with 2 academic supervisors who will be a bit more involved in the project. Others there will be a second supervisor, but they will be there to support where the other one can't, as opposed to being involved day to day. The key thing about an academic supervisor for research is that they're there to give you advice and direction. So they won't give you day-to-day tasks, they won't map out everything you need to do, they're just there to give you some suggestions. You go off, do your research, and you have a discussion about what your results and your theories are. And ultimately the project is yours, so it's up to you. You can make it whatever you want to. So give it a steer, go off in some directions, try new things. All the opportunities are there for you. The other thing is we mentioned about the cohort. So a quick definition: a cohort is a group of people who share a characteristic. So it's a word we throw around a lot where we work, but ultimately what we mean is there's a group of people like these guys here who are finishing that year. It's a group of people who are going through a similar journey. So the journey is going through your research project. So you're not alone. There's a lot of people who you can share ideas with, get support from, or just go and have a drink, have a cup of coffee and have a chat with as break your day up. Talk about some of the things you've done, share a bit of knowledge, and really does help along the process, having all these people around you. The other thing we do as part of a cohort is there's a lot of activities. We want to support as much cohort building and as much knowledge sharing as possible going on with you guys. So there's lots of student-led activities. So there's examples up there where a group went off paddleboarding out in the bay. We've also got another example there where this guy James here was taking part in the young person's lecture competition with the Institute of Materials, and that's in Armourers Hall in London. Through to some research talks. So this is a series of research talks we held in the Gower by the Corrosion Group, and then other things we've got. So we've got course reps to help share concerns and positives. We've got outreach, as I mentioned, getting out into the schools, journal clubs, local society talks, seminars. Or if you've got an idea, come to us, create your own idea, and we can really go forward with that. Another thing we do as a cohort is the industrial tour. So it's a chance for us to share some of the real world manufacturing processes. So trying to give you that appreciation of what we do at a university scale in the labs, but also what we do what can be done in industry. And we go to a range of sites around the UK. So the 2 examples in this picture where we've been to Lotus and we've been to Airbus. But we also go to a lot of other sites. So we've been to Atomic Energy sites, we've been to Jaguar Land Rover, JCB, just to give you that feel for what this large scale manufacturing can be like and how that compares. So that's typically in your first year, COVID depending of course. The other event to touch on is the annual conference, which is held every year in our great hall on the university. And that's the idea that we give all our students an opportunity to present their work, whether you're given an oral presentation like this or you're putting your posters up that can be seen on the back wall around the hall. And it's a great chance to get together, have a chat and share your ideas and show off what you've been doing basically, because everything that everyone's doing is really worth celebrating. Other events or conferences, we touched on it earlier. There's a fantastic opportunity there. We don't always get the chance to do this once you're out in employment, so it's a great time to make the most of it. So if you're able to get a paper accepted and you give a presentation, then we'll support you going. So we've got a couple of conferences around the world. So both of the top left and top right, we're in in Tokyo. We've got people around San Francisco Bay, Sydney. We've been to Hawaii. Closer to home, then Nice, Paris, London, Birmingham. This one is up in Liverpool. So there's fantastic choices for places we can go and attend these different conferences. Some of the FAQs we get asked then, so where will I be based? Most people are based at the university. Some of our projects will share the location, so some will be allocated at the university, but they'll also spend a fair amount of time with the industrial partner. Others may find that the project will stipulate a lot more time needed at the industrial partner. So take a look at the adverts that we're putting out, and that we were including information on there about if you expect to spend a bit of time away or not, just so it's clear and to make sure that you understand what you're getting when you apply for these projects. Important stuff. When do you get paid? So you don't get paid the money all in one lump sum. I think most of you will be glad to hear. So it's paid like a salary. The big difference is you're paid a month in advance instead. So as soon as you enroll, if you're successful, then we go through it, and you get paid in a monthly instalment as you continue. Can I visit my sponsor? Of course you can. There are travel restrictions. Good news is that they're easing. But we really encourage you visiting your sponsor sites. Can you access the labs? Yes, we've learned how to live with COVID. There are restrictions in place at the moment in terms of volumes and things like that. You need to have an induction, but everyone's in the labs, everyone's getting on with their work, and it's a really good environment to be in again. And the other thing, I need something for my project. Can I purchase something? Of course, yeah. So all our projects come with a generous budget in place. We've got lots of procedures to follow to make sure we follow our funders' rules, but a lot of the time we're able to support most of the purchases that our researchers need, so we can help support that process. So what do we do? It's a quick snapshot. So there's a broad range of different projects going on within the groups, and they ranges everything from looking at the influence of raw materials in steel making, the process inside of steel making. So this is looking at thermal losses in steel making vessels, through to we had a project running looking at how you can use softwood and make it act like hardwood. Looking at renewables with the wind turbines. This is fire retardant foam, hydrophobic coatings. Looking at some of the corrosion reactions down here. We've got ALM processes or additive layer manufacturing, and then in the picture here we've got the active classroom and active office, which are in the base. That's something that's been developed through the research that we've been doing. We've actually got these buildings which are established as off-grid. They can generate their own energy. They've got their own heat. So all they need technically going into it is water. And the good news is that our classroom is there as well. So we actually teach out of one of these demonstrator buildings. So it's a fantastic opportunity for us to share some of that research. Another snapshot of what we do. We've got the fresh food packaging solution. So this researcher, this is Ala here, whose research was set out to look at, can we replace some of these pads that end up in meat trays. So meat goes through this. Once it's stored, then it goes, you produce what's called meat exudate, which is the juices basically coming out of the meat, and that can have an issue in terms of appearance, but it also has an issue because it can release a smell as well, even though the meat is perfectly fine. Historically, then a lot of the meat trays have been put in these pads in the bottom, which are designed to absorb the fluid. One of the issues with that is they end up in landfill, and it influences the recyclability of the packaging. So the work Al has done is actually designed new capillary vessels or capillary effect within the packaging, which means that as the juice occurs, it gets drawn into these cells instead. So there's no additional components needed. There's nothing going into landfill, and you can actually rinse these out with a tap at the end, put it in the recycling, and the entire packaging gets recycled again, made out of PET. So it's fantastic research. The big thing about this, so it's not just research. Within his 4-year doctorate, the company who was sponsoring MKP have actually been able to convert his idea into a product, and it's on shelves in supermarkets now. So there's a range of supermarkets within the UK who are actually using this product on their shelves. So next time you're in the supermarket, take a look at the bottom of the tray, and you may well see some of Ala's trays there. So that's a nice thing. Another thing we focus a lot on, and we're really encouraging, is sustainability. So all our projects seem to have a sustainability element tied into them. Some of the key focuses are renewables, so we've got some interesting examples here with renewable solar panels that we use on and we were looking at drying basically human excrement and turning that back into fertiliser. So that was a project with universities in South Africa and the Bill and Melinda Gates Foundation to bring sanitation to part of the developing world. So that's really interesting. Through the photovoltaics, energy storage is a big part. So as we start to produce all this renewable energy, can we store it for when we need it? And then through to there's a nice snapshot of Tardis in the background there, but one of the big decarbonisation challenges. So there's a lot of projects coming through now which will focus on decarbonisation as well. So how do we reduce our CO2 emissions? So COP26 recently, outlined a lot of the things we need to do, and we're seeing that type of stuff coming back into our research projects. So one of the key things about what we do with our projects is understand the impact. So just to give you a snapshot of what's going on. So at the end of the first year, we try and focus our research onto what the impact of their research is. A lot of the time we can get caught up in the nitty gritty of what we're trying to achieve, but we also have to be mindful of why we're trying to do the small science, what's the scale up and the big size of it. So this is just one example of Henry, who's been looking at cluster beam deposition for catalysis, who's actually based in the diamond synchrotron facility in Oxfordshire, and the idea is that we're able to produce some more sustainable manufacture. We can reduce greenhouse gas emissions, and we can reduce the cost of chemicals we use it if we're able to go through the synthesis for this process. Another example of work with Molly's doing with a company called Power. This is looking at how we can help produce what's called perovskite photovoltaic modules using particular substrates to see how they can work together. So again, helping bring photovoltaics to market. And then there's other examples then of how we can use different automotive clear coats with different benefits compared to the conventional solvent-based paints we're using for that. So they're just snapshots of quick visual ones. Other things celebrating the success, really pleased for one of our researchers, Caitlin, was highlighted last year as one of the top 50 female engineers to watch by the Women's Engineering Society. So there's a big accolade for her, really proud of what she's achieved. So she's done a lot of work, a lot of outreach work as well as her own research, and I'm really pleased with her. And off the back of getting that accolade, then she was offered employment as well. So that's a great success. That's what we're seeing there. So using that to lead on to the opportunities, as we mentioned earlier, the employability rate is 97%, so really good. And then the questions over what roles do we see our students going into? We've got the material scientists, we've got process technology specialists, technology transfer fellows, which are research inside the university, project engineers, quality engineers, R&D engineers, software engineers, all sorts of engineers. Is fantastic. Through to some with startup businesses. We had 2 students graduate last year, got to know each other coming through university, and they decided to start their own company up, which is really keen. They're doing well, so good luck to those guys. And the last one on the bottom there is a medical student. So if you haven't had enough education, well, actually you can look at some of your postgraduate entry routes into medicine. So that's what he decided to do. So he's gone back in as a medical doctor now, but he's doing really well. So highlighting some of the alternatives. Many graduates then we've got to take on senior roles. So back onto that progression we're showing. So when we try and track some of our alumni, what we see is a lot of people now sitting things like they're directors of companies, technical directors, managing directors. We've got technical managers within a lot of companies, so leading the development, leading academics within the university, and something a bit different. So one of our alumni is a weather presenter on the BBC as well. So lots of opportunities. As I said, highly employable. 97% of our students get into a role. Just profiling some of our high achievers. So we've got Professor Martin Brunnock, who's Hub Director at Tardis UK. So he came through in '93 and has done extremely well. We've got Fiona, who's an Enterprise Excellence and Business Transformation partner. So she's helping businesses develop now. She's taking her understanding and helping people develop. We've got Pia here, who's the Director of Tailings and Water Processing Testing at Metsu Tech. and then Jim Boughton is a director within GlaxoSmithKline. So just trying to give you something to aspire to, or some examples of where you can end up within the world of industry off the back of coming on our courses. Some more examples of the alumni then. So we've got Dr. Natalie Wint, who's a senior lecturer, Dr. Lewis Berry's business unit manager, Sam James, raw materials specialist, James Kerr, design and engineering director, Amy Luck as a munitions life assessment engineer. We've got John Davis, the cloud solutions architect, and then Ben Morgan's a teaching tutor in the university, and Alan Winrose, a technology transfer fellow. So just to give you an idea of, so these guys have graduated all within the last 10 years. I'll just give you a feel for the different roles that people are managing to go into. One of the things we get asked a lot is, if I'm going to do a doctorate on coatings or corrosion, does that mean I have to work in coatings and corrosions for the rest of my life? Certainly not. We do not get typecast off the back of our research. So it's about how we apply those skills. So researching effectively is solving a problem. So by getting your qualification, you're achieving a recognition that you can solve problems, and it's how you apply that then. So I'll give you an example with Amy Lucker here. Her research was looking at CO2 absorbing coatings. Now she's a munitions life assessment engineer at the MOD. John Davis was doing his research into corrosion. Now he's a cloud solutions architect within Microsoft. So there's a range of things which you can go into, and it's a very transferable skill in terms of what you achieve via your research project. Focusing very much on the now then, these are the projects we've got available for this year. So there's 4 MSc projects out at the moment. We're expecting a few more in time, so if you're really interested in the MSc options, then keep checking back onto our website. So we've got one with Cubex looking at the performance of concrete products, so it's a really novel product there. One with Welsh Water looking at the treatment of contaminants in wastewater, so how we approach some of the new contaminants going into the water flows and how we can remove those. One with LSN diffusion, so they produce fine metallic powders, so it's trying to optimize the process. And one with Zeiss microscopy, looking at in situ microscopy for the heating effects of steel. So normally we do a lot of heat treatments or thermomechanical treatments on metals, and then look at them in the microscope afterwards. But this one is trying to explore, well, can we actually visualize these processes as they're going on within an electron microscope? So quite interesting. We're a big partner with Tata Steel. A lot of research going on at the moment. So these are projects specifically focused with Tata Steel. So there's a good range of projects. We've got a series of projects with Tata Colours, who make organically coated steel. So we're looking at different weathering of the organic coating, see what the impact of sunlight, weather, rain have on the degradation or colour changes of organic coatings. We've got solvent-free paints, so looking to move away from solvents. So if any of you have ever gone near a paint factory, then there's a good smell. If you think about putting gloss paint on your wood in the house, that's the solvent coming off as a smell. So trying to explore how we can get paint which has high performance, but we're trying to move away from using the solvent. Sustainable curing, exploring alternatives. As for that, so usually we're curing in ovens. Can we use different techniques? Can we use UV? Can we use infrared or even microwave curing to try and get the paints to cure? One looking at liquid metal embrittlement of high strength steels. So that's when some of the issues around when we're welding, we can create embrittlement and point of weakness within, and particularly within high strength steels, and that's typically on a galvanized product. Next generation inhibition of cold rolled steel applications. So this is more of a focus on what the oils are as opposed to what the of the inhibition, but that's looking at, can we put certain oils on the surface which can be removed during the manufacturing process and have a good life cycle, so there's no issues within those. And then one looking at casting, so as we move away from conventional steel making, can we reduce the thickness of cast steels, and being able to understand how we can produce the current steels that are made in the standard route. As we move to new routes, are there different ways which we can achieve the same properties? The next one down is understanding alternative coating and texturing technologies for work rolls. So work rolls are within the steel industry, so that's what the steel gets passed between the two rollers. So wear on those surfaces is really important. It can't be done with chrome coatings which are deposited from chromium-6, which is being phased out due to REACH legislation, so we're looking at alternatives for that. Refractory systems is looking at how we can coat the surface to reduce the thermal losses. So we showed a picture earlier on of some of the thermal losses on the ladle. So how can we use different refractories to maintain that? And then the last one is the corrosion performance of low tin coatings. So can we produce different tin coatings, so thinner amounts of tin on the surface of food packaging, so like your big bean tin, to get the same level of protection. And reduce the cost of the packaging. Falling outside of the Tardis one, so we've got 3 other projects available. One with a company called Tritech, which is the spin out of Howell Health Board, and they're looking at health technology. So this is transdermal sensors for diagnostic applications, just looking at respiratory issues. Can we actually monitor people using sensors on the skin to try and understand some of the issues? And then we've got 2 Zimmer Peacocks. We've got platinum hybrid centers for the food and automotive market, and we've got smart batteries based on printed hybrid sensors as well coming out of those guys. So it's looking at some of these novel technologies to produce some solutions here. So coming towards the end then, so what is the application process? So it's a competitive process. So we're advertising the projects. We've got 10 slots to fill for the doctorates, and we're expecting 10 masters. So the 10 best candidates basically get through. So it is an interview process. The deadline is the 25th of February. Put it in your diaries. It's not that long away, so make sure you're mindful of that deadline. Get your application in online. It's via our website, m2a.wales. And one of the key things about the application is make sure you include relevant information. We're not expecting you to be an expert. We're a training program. So we don't expect you to solve all the problems now, but you have to be able to relate to what that problem is. Likewise, when you're picking your problem, make sure that the project you're picking is something which really interests you. You're going to spend a lot of time focusing on that. So if you're not sure if you're interested on that one, come and have a chat, find out a bit more about it. There's contacts via the website, via some of the links in this presentation. Come and have a chat with us and make sure you understand them. Once we receive the applications, then it goes through a shortlisting process. So one of the things we're doing this year is we're trying to remove any potential biases, whether it's conscious or unconscious. So all application forms are going to be anonymised prior to shortlisting. So all that we're going to have to go off is what you guys put in your application forms. So make sure that you focus in on the relevant information. Really look to sell yourself. And then as we go through it, interviews, they're likely going to be via Zoom, where you give a short presentation. And that presentation itself is not there to really push you guys on terms of your presentation skills. What we're looking for you to transfer some of that knowledge. So we're looking for you to demonstrate that you can do a little bit of background research and try and show that you can understand what the problem is. So we're not expecting you to be an expert, but we're looking for you to just gain that background knowledge and present that to us. So we're not going to, you won't be marked on the actual presentation skills on those. And then we've got a series of interview questions that we'll work our way through as well around the projects. So if you're successful, you'll receive an offer. A lot of eligibility checks, and subject to all those pass, and then you get a firm offer, and you'll have an induction with us. It's usually either the end of September or the first week of October, depending on how the calendar falls and what other commitments are going on at that time of the year. So that's the gist of the process. There's a bit of support available. So what we've got, a book and drop-in session. So if you're not sure, you'd like a bit of guidance of how to word your application form, or again ask some questions about the projects, get a bit of clarity, then again there's opportunities. Scan the QR code here, or go on our website m2a.wales and follow the link, and you can book a session, have a chat about filling the application form in, what information you include, how best to word it. You know, ultimately what we want is the best person. We're not the best person who can fill a form in, we want the best people who best person for the best projects, and that's what we're trying to achieve. So we can give you a bit of steer. We're not going to fill the application forms in you, but let's make sure we can draw that information out that shows you off at your best. So don't forget, 25th of February, that's the deadline. That's what we're working towards. Get your application in via the website. Any questions, then please fire them off to m2a@swansea.ac.uk, and we'll be sure to get back to you at the earliest convenience. Okay, thanks for listening. I really hope that's been beneficial to you guys, and they say lots of information on the website. Get in touch if you need to, and we look forward to hearing from you and seeing your applications. Thank you.